Have you ever stared at a math problem and felt like it was playing tricks on you? You know, you get one answer, your friend gets another, and you're both looking at the exact same question? Well, you're not going crazy. And today, we're going to crack the code that solves this whole mix-up. Okay, so check this out. We've got two students, one simple problem. 3 plus 4 times 2. But one of them gets 14 and the other gets 11. How does that even happen? Is one of them just better at math?
So, who's right? Well, here's the thing. It has nothing to do with being a math whiz. It's all about following a secret code, a set of rules that everyone agrees on so we can all speak the same math language. And that secret code? It has an official name. The order of operations. You can think of it like the official rulebook for math. It's what mathematicians all over the world use to make sure that a problem has only one, and I mean one, correct answer. Now, you might have heard your teacher talk about BEDMAS, or maybe you've heard PEMDAS. It can be kind of confusing, right? But here's the big secret. They're exactly the same thing. Brackets and parentheses are just two different words for the same symbol. It's like saying soda or pop. Different words, same fizzy drink. But why do we even need rules like this? Well, it's all about making things clear. Imagine trying to build something with instructions that could be read two different ways. It would be a disaster. These rules make sure an equation means the same thing to me, to you, and to an astronaut on the space station. It's math's universal language. Okay, so if we're going to master this code, we have to know the common traps. Understanding these is the first big step. So let's kick things off with trap number 1, the parentheses package. Think of parentheses, or brackets, same thing, like a special package that just arrived. Whatever is inside that package, you have to deal with it first. It's a package deal. You need to figure out what's inside before you can do anything else with it. And here's where people get tripped up. Some students see parentheses and their brain just shouts add. But that's not what they mean. You have to do whatever the operation is inside the package. Whether it's adding, subtracting, multiplying, whatever it is, it gets done first. All right, let's level up. Now that we've got the package deal down, it's time for trap number 2, the exponent power-up. Exponents are kind of like the super-powered operation in math, so they get really high priority. So what is an exponent anyway? It's that tiny little number you see floating up at the top right of another number. It's just telling you how many times to multiply the main number by itself. So 5 to the power of 2 isn't 5 times 2. No. It's 5 times 5. They're called powers for a reason. They make numbers get big fast. Now you have to see this because this is where those little parenthesis packages become so important. Look at these two expressions. They look almost the same, right? But that one tiny difference, the parentheses, changes the answer completely. Let's break down the one with the parentheses first. Remember our package deal? The parentheses are wrapping up the negative sign and the 3 together. So we're multiplying the entire package, -3, by itself. And what happens when you multiply a negative by a negative? You get a positive. So the answer is +9. Now look at the one without the package. According to our rules, the exponent gets handled before other stuff. That little 2 is only stuck to the number it's touching, which is the 3, not the negative sign. So you have to calculate 3 times 3 first, which is 9, and only then do you apply that negative sign waiting out front. So the answer is -9. See the difference? So here's a quick rule to help you remember. If a negative number is snug inside parentheses, an even exponent, like 2, 4, or 6, is going to give you a positive answer. But if there are no parentheses, the answer will always be negative. Okay, get ready, because we're about to bust the single biggest myth in the order of operations. This is the trap that BEDMAS and PEMDAS accidentally set for us. I like to call it the left to right lie. Here's the absolute truth. Multiplication and division are partners. They're on the same team with the same level of importance. The M does not mean multiplication always gets to go before the D for division. You just solve whichever one comes first as you read the problem from left to right. And guess what? It's the exact same deal for addition and subtraction. They're partners too. Once you've dealt with all the powerful stuff like exponents and multiplication, you just solve the addition and subtraction in whatever order they show up, left to right. The A for addition does not get to cut in line in front of the S for subtraction. They're equals. All right, we've learned the secret code, we've spotted the traps, and we know about the partnerships. Now for the really fun part. Let's put it all together and see how this works in the wild.
Let's go all the way back to our first problem. 3 plus 4 times 2. So student 1 did the addition first, right? 3 plus 4 is 7, and 7 times 2 is 14. But now we know that's falling for a trap. Multiplication is more powerful than addition. Student 2 got it right. You have to solve 4 times 2 first, which is 8. Then you add the 3. And that gives you the one correct answer, 11.
Let's practice with a new one. We've got 6 squared plus 14 divided by 2 minus 8. Okay, what's our most powerful operation here? That exponent. 6 squared is 36. So now our problem is 36 plus 14 divided by 2 minus 8. What's next? Well, we see a division sign. 14 divided by 2 is 7. Awesome. Now we just have 36 plus 7 minus 8. It's just addition and subtraction left, so we just go left to right. 36 plus 7 is 43. And finally, 43 minus 8 gives us our final answer, 35. We did it. So just keep this little checklist in your head. Remember the partner rule, left to right for multiplication and division and for addition and subtraction. Always do powerful exponents before you do weaker stuff like addition. Be super careful with those negative numbers and parentheses, and never ever ignore a package deal.
And that really shows you why this is all so important. These aren't just a bunch of random rules made up to make your life harder, I promise. This is the grammar of math. It's what makes sure we're all on the same page and speaking the same language, so we can build and discover amazing things together. It kind of makes you think, doesn't it? If you step back from the math, where else in life does having a clear, agreed-upon order of rules help us avoid total chaos? Something to chew on. Have you ever